Hello students, welcome to Edusil. In this video basically we are going to solve a question which is a weighted set cover problem. So here the algorithm is given. Based on that we will be following the concepts and we will be finding out the set cover as well as the optimal set cover. It asks us the question. As I have already told you, like in the detailed video, those who are new kindly watch the detailed video. There you will get like how we will get the set cover as well as the optimal set cover. First of all, as per the book, we will be starting. Then we will be following this algorithm approach to find out whichever is best for us to pick. Okay. So initially, what you have to do is the universal set is it's U. First, you write all the elements 4, 5, 6, 7 and 8. Then you have set which are S1, S2. S1 is 1, 3, 5, 7. S2 is 2, 4, 6, 8. 2, 4, 6, 8. S3 is 1. S4 is 2. S5 is 3, 4. S6 is 5, 6, 7, 8. Suppose such questions are being asked based on the weight assigned to each element. First of all, you must write that one. The weight W1 is 1 plus epsilon. That epsilon actually lies in between 0 to 1. You might be writing in this way. So either it 0.5, 0.2, 0.3, whatever it is, it's definitely more than 1 that we know. Okay. So W2, which is weight of next is epsilon, W3, W4, W5 and W6, which is the weight of each subsets, are considered as 1 initially. Okay, so our target is we have to collect a set cover. Basically the set cover we have to do. Set cover is like all the subsets. If you are going to combine, that will be giving you the universal set. So our target is basically we have to find out the set cover. So as per the approach we have to follow, like R is infinite, before that R is equivalent to U. So R is equivalent to the set, universal set. Next what we have to do is we have to find out for each element W means the weight divided by the intersection. So as per the step 1, for the iteration 1 I am just writing, or you can say iteration 1 or step 1. For iteration 1 and for S1, what we can do is like the weight is 1 plus epsilon divided by uh, the weight. How do we say, like S1, which is, you can say, the elements present 1, 3, 5, 7 intersection with 1, 2, 3, 4, 5, 6, 7 and 8. To minimize the time, I'm just writing for one step and I'll be detecting like what you have to write in future. Like it is 1 plus epsilon divided by, you can say after intersection, the the elements present there is this one. Okay. So 1, 3, 5, 7 after intersection. This set theory basically we are using. 1 plus epsilon divided by 4, because 4 items or 4 elements are there. So you can say it is 0.5, sorry, 0.25 plus epsilon by 4. Epsilon is anything, but definitely if I consider with others also, because we are now discussing with the iteration 1, for one step I have written, and for others I'm just detecting it. For S2 directly I'm writing 1 plus epsilon divided by, whenever we are saying S2 intersection R, so R value is this one and intersection you are doing, so definitely I am writing 1 plus epsilon divided by 4, because 4 elements are there, and intersection you are doing the same thing you are getting, so as you have seen here. So 0.25 plus epsilon by 4, and for S3 it is 1 by, because weight is 1, and S3 intersection R, so S3 the item is 1, so 1 by 1, which is 1, and S4 uh, weight is 2, sorry, weight is 1, but the elements present here is 1 by, the elements is also 1. Next we can say for S5 1 by S5 intersection R, which is 1 by 2 is 0.5. Now for S6 is within this, S6 is 1 by S6 intersection R. The number of elements are like, if you intersection, so the elements you can find out this one 5 6 7 8. So 1 by 4 is equivalent to 0.25. This 0.25 is a minimum. Okay, so minimum, as for this one, like it is written the minimizes, so minimum will be picked. So why not others like 0.25 plus epsilon, because epsilon lies between 0 to 1, that's why you should have to keep in mind. So definitely it is more than, at least if it is 0.001 na, so 0.25 is definitely less than 0.250001, because this epsilon is having certain weightage. If it is getting added, as you know, it's a basic idea, so that's why I'm telling you. So the S6 is getting selected. As for this one, if I'm selecting this S6, so I have to select in a S. Now S will contain S6. Next, what we have to do for the first iteration, now we are just discussing iteration 1. So I1 I'm just writing. We are right now in I1. Then delete Si, which is getting selected. Now the R is R minus S6. Minus means we are removing these portions. Like after removing this 1, 2, 3, 4, 5, 6, 7 and 8. So as per the algorithm, it is written R equal to R minus Si. Si is S6. So S6 is 5, 6, 7, 8 minus 5, 6, 7, 8. I need to verify that whether it is 5, 6, 7, 8. Yes, 5, 6, 7, 8. Now we have to remove this. So the left element is 1, 2, 3 and 4. Clear? Next, iteration 2. Now for the iteration 2, S6 will be removed and S1 we have to start with the S1. S1 again the epsilon 1 by epsilon 1 plus epsilon divided by the elements present there is 1357 1357 intersection 1 2 3 4. So out of this we know the intersection. How do we get it? 1 plus epsilon, then the existing is 1, then 3 and nothing is there instead of this one. So we can say 1 plus epsilon by 2. Then we can expect 0.5 plus epsilon by 2. Why I'm saying epsilon always? Because epsilon is having certain value. We don't have to decide that one right now. But it is definitely lies in between 0 to 1. So for S2, the same procedure I'm following by skipping the direct answers. Writing here, I'm just writing this one. So you can expect like 2, 4 from this 1, 2, 3, 4. 2, 4 is there. So it's divided by 2. 1 plus epsilon, because 2, 4 will be the answer in between. So I'm just writing this 0.5 plus epsilon by 2. Next S3, which is 1 divided by 1 is there. So definitely I'm just writing S3, which is intersection with this. So 1 by 1 is 1, and S4 is 1 by S4 epsilon R, 1 by epsilon. This represents 2, so definitely 2 is there within this. So one element will be the answer there. S5 is 1 by S5 intersection R. So 1 by S5 contains 3 and 4, and 3 and 4 is there. So definitely I must write two answers here. 0.5. 0.5 is the minimum. So though it is minimum, so what we are doing inside it, our iteration 2, this you know the previously it was S6, now we have to union S5 here, then S equal to S5 S6. Okay, so next is uh, the R value was previously 1, 2, 3 and 4. Now it is getting deducted by the 3 and 4. So the left value is 1, 2. Next iteration 3 or iteration 3, here S1 will be 1 plus epsilon will be the weight of it, and the elements it captures are 1, 3, 5, 7, 1, 3, 5, 7 intersection with 1, 2. So definitely you can get the value as 1 plus epsilon by the value present, only 1 will be the intersection. So 1 by epsilon by 1, which is 1 plus epsilon. Epsilon value ranges in between 0 to 1. So might be 0.5, anything it is. So 1 plus epsilon divided by S2 intersection R, which is epsilon, like 1, 2 is there. So here only 2 is a part of it. So I'm directly writing one element could be found out. Next S3, 1 plus epsilon, sorry, here is 1. So S3 intersection R, the value is 1 only here. So I must write 1 by 1, which is 1. S4 is like this, 1 by S4 intersection R. Now we can expect 1 by 1, which is 1. So out of this 4, you can take 2 are minimum. So I'm just collecting this one S4 or else S3. Anyone could be picked. So both are minimum. So I'm just writing here it is minimum. Here it is also minimum. But I'm selecting S3. Select at least one. Okay. So as for this, I'm selecting S4. So if I'm selecting S4, any could be selected. I'm writing anyone could be selected, but I'm just selecting I'm just adding S here as S4. So S4, S5 and S6, this is now I have added within this, and the R value will be 1, 2 was previously there. So 2 is getting deleted, I think it's S4, 2 is getting deleted. Now the value present here is 1. Okay, so very next iteration, 4, the R value and S is known to us. Next, S1 will have like 1 plus epsilon. We have 1, 3, 5, 7 are the elements, and the R value is getting updated now. So what we have to do is 1 plus epsilon, only 1 present, so we can write it as 1 plus epsilon. Here the same thing was there, so here also we are getting epsilon. S2 1 plus epsilon divided by S2 intersection R epsilon by 1, which is 1 plus epsilon. And for S3 I can write 1 as a weight. Here S3 intersection R, which is 1 by 1, because 1 is there, you know? So that's why I'm just writing here it is considered as minimum, because anything if it is 1.001 is definitely greater than 1. So that's why I'm saying, so here is it is minimum. So if it is minimum, then S value is uh, you can say S3, S4, S5, S6. The weight they have gained as 1 plus 1 plus 1 plus 1, which is 4. They are definitely a set cover for us. This is definitely a set cover for us, and this is the weight of set cover. But this is not optimal. Clear? And you know the optimal will be as per this 1357, and if you combine these two, the optimal could be written as S star will be S1 and S2. Why? Because if you combine this 1357, if you union this two, 2 4 2 4 6 8, so definitely it is equivalent to U or equivalent to the R, which we have already taken. But based on that, the weight for this one is 1 plus epsilon plus 1 plus epsilon, which is 2 plus 2 epsilon, or you can say which is 2 into 1 plus epsilon. So this is definitely less than the weight star is less than W. Clear? Why? Because you can say 2 1 plus epsilon is definitely less than 4. Clear? As per the book, I can show you the picture. Here I am just writing 1, 3, 5, 7. Here is 2, 4, 6, 8. In the Venn diagram, I am just changing the color for each set. This is S1. This is S2. There in a detailed video it is clearly mentioned. You please visit that one. And for this is for S3, I think. S3 is one. Yeah. This is S3. This is S4, and 3 4 is S5. 3 4 is S5. 5 6 7 8, which is left is for S6. So as for the Venn diagram, this is represented as this. So you know, in the detailed video, you might have seen the weight assigned here is 1 plus epsilon, 1 plus epsilon. But here the weight assigned as 1, 1 and 1. But we are indirectly taking this one, and the universal, I am just changing the color for the universal. This is U for us. this is our U, okay, or R, because U is a, I know, universal set. We are just converting that to R, as it is clearly mentioned in the detailed video that we are taking because of we are manipulating in future. So the weight actually, if you combine this, so the optimal could be 2 plus epsilon, but which is we are not getting. It's less than that because epsilon belongs to 1. Suppose you can say, sir, we cannot giving the proper idea because see, the maximum value of epsilon is 1 that you can take because it ranges between 0 to 1. Suppose I am telling you, now you take the value, the maximum value of epsilon is 1. So if I am taking the maximum values of epsilon is 1, then in between that I have to write this one, clear? So definitely what you are expecting is 2 into 2 is 4. Okay, this is your W star, but W is fixed, is 4. But this is the worst time. I'm just telling you, if I'm taking the maximum, definitely I'm getting 4. But the 4 is maximum we can expect. But less than that could be possible because it ranges between 0 to 1. So if I'm taking zero point 0.5, so you can think of if it is taking zero point 0.5. So zero point 0.5 means 1.5 here, 1.5. So definitely 2 into 1.5 is 3. 3 is less than 4. Clear? So this is how we can measure the weight with the set cover. Basically our target is to find out the minimum weight set cover. Here we are not getting it. In the detailed video it is clearly mentioned. I hope it is clearly understood by you. If any doubt, please comment below. Thank you and have a good day.